Hello and welcome to today's lesson. Today we're going to look at solving by the method of graphing. Now before we start that, I want to refresh your memory just what a graph actually is. So suppose you had some kind of a equation, say something like this. Y equals 2/3 x plus 1. And I go ahead and I create the graph. Now what I might do here is I might use the idea that the 2/3 is the slope and the 1 over here, this positive 1, is the y-intercept. I might use that knowledge to make a very quick graph. So I know I'm crossing at positive 1. And my line has a slope of positive 2/3. That means a run of 3, so 1, 2, 3, and a rise of 2. So my line's going to go through these 2 points. Okay, so there's my graph, but what actually is a graph? Well, a graph is a collection of all these millions of points. Okay, all these millions of points that make this line, and all of these points have one thing in common. If you replace the x and the y with the coordinates of any of these points on your graph, they make the equation come true. For example, we have a point up here. The coordinates look to be 1, 2, 3 to the right, and up 1, 2, 3. So we have the coordinates 3, 3, and that's a point on our graph. Now if I put 3 in for the y, and I put 3 in over here for the x, I should get that the left side makes the same number as the right side. So left side is 3, and on the right side, well, I can cancel these 3's here. I'm going to get 2 plus 1, which is also 3, and so the equation is true. Now that's going to be true of any of the points that are on this graph. If I can figure out their coordinates, they will make the equation true. So now let's use that knowledge and solve a system of equations by graphing. So let's clear off the screen, and we're going to produce a grid, I think. And my equation, my system, is going to look like this. So somebody says go ahead and solve the following. One equation is y equals 1/2 x minus 3. And the other equation is y equals negative x plus 2. Well, what we mean by solving the system is we are looking for the point that makes both equations work. Both equations become true. Now to find that point, I'm going to graph each of these lines. I'm going to graph the first line. It has a y-intercept of negative 3. So 1, 2, 3. And it has a slope of positive 1/2. So that's a run of 2. And a rise of 1. So there's that line. I'm going to see if I can do a good job of actually graphing the line. Something like that. So there's that first line all graphed. Keep in mind these are all the points that make this equation true. Now I'm going to go ahead and graph the second equation. So it has a y-intercept of positive 2. And a slope of negative 1. I'm going to think of that as negative 1 over 1, which tells me it has a drop of 1 with a run of 1. So let's draw that line. Alright, so there's the second line. Now, what is the solution? Well, the solution is the one and only point that's true for both of these equations. And that's this point, because this point is on both lines. So there's our solution. And we eyeball it as best we can. It looks like 1, 2, 3 and a bit, so maybe 3.3. and it has a drop here, a y value of -1, maybe -1.2, something like that. Okay, now that's the one and only downside of this method, is that you kind of have to eyeball these, so it's unlikely that everybody gets exactly the same solution. But as long as you're close, you've done your job. So I'm going to stop there, and we have our approximate solution here. We know it's going to be around there, so it's a good place to stop. We're going to catch you later.